Hello everyone and welcome to I'm your data scientist.com. This is Yogesh. So what I'm going to do today is show you how to analyze or do data science, machine learning using two different tools. So one with using R, the statistical computing language, and the other one is using AWS as machine learning services. So we will try and analyze the output of both technique and try and compare how it performs. So let's, without further ado, let's dive into it. So here I'm in machine learning. But before that, I just wanted to show you what data set I'm going to use. So the data set I'm going to use is the Indian liver patient data set, which was released in 2012, May 2012. It has about 10 attributes. It's a classification task. The variables such as age, gender, total TB, DB, then the last field, which is whether the patient has a liver, patient is a liver patient or not. So there are in the data sets we've got about 416 liver patients with plus 167 with non-liver patient records, which has about 142 female patients record, and these are the general information about dataset. So you can just go to machine learning repository and search for ILPD or Indian liver patient dataset. You'll get. Also, I'll be copying this dataset into my R, so don't worry about this. I will also share this code on my GitHub channel. So first thing is to extract that data. So here's the data. I have extracted data and assigned that as a data set. So before going into R, because machine learning will take some time to create that model, so we will go and create a AWS machine learning model first, then come back to R and toggle between them. So let's go to R machine learning. So yeah, it's under machine learning. There's tab and click get started. If you haven't used it before, then click standard setup, launch, and let me just check if I've got that dataset in my dataset. Yeah, there we go. I've got that dataset in my S3 bucket. I'm sure you know how to upload the data. So you just click upload and add file, select whatever file you want and click upload. And if you can set permission on dataset, there's lots of things, version control, events you can do. So there's so many things you can do with data lake or S3 in AWS terminology. So I've got that data set in my S3. So where it's saying either, so the Amazon machine learning accepts two data source, which is one is S3 and one is Amazon Redshift. So I know that folder and the file I was referring to, and I would name that as to say Indian liver patient data and verify. So it's verifying. So it has detected that, yeah, it does have that data set. Click continue, and in here it says, does the first line in your CSV contain the column name? Yes, it does. So you can see it has detected the first name, and click continue. The target variable we want to predict is the patient liver patient or not. So yes and no. So just to let you know that when I downloaded the dataset, the raw dataset, it had number 1 and 2. So 1 stands for yes, the patient is liver patient, and 2 means not. So I had to convert that and change that into Y and N. So yes and no, binary, that is. So I've selected that as a target variable. We want to predict that whether the person has person is liver patient or not. Let's continue. No, we don't have any identifier. Review and click continue. So and now it's ready to create. So it's got some default recommendations. You can create your own custom algorithms, for example, modify training parameters, so on and so forth. But I'll go with default for the time being, and click review, and you can see all those data source ID and ML name and evaluation models and so on and so forth. So click create ML model. So currently the status is pending. So this will take just about 5 to 7 minutes to generate model. So meanwhile it is creating. Let's jump over R, and let's try and do some of the machine learning here. So first thing first, what I want to do is I want to call that data. Let me just clear Control L to clear the console, and if I was to drag that up a bit. So let's start from beginning. So data, then I want to see the structure of data. You can see it's got about 153 observations, about 11 variables, and you can see the predicted variables, which is factor. Before it was 1 and 2s, as I mentioned, but now it's converted into N and Y. And it's got other variables like, for example, age, gender, total bilirubin, SPP, PG, PT, so on and so forth. Total protein, albumin. These all are scientific terminology, I think. But anyway, let's look at the, and again, it didn't have the column name, so I had to go to the actual data source, which is actual data source, and copy all those and add that to our data set. So this is how you do it. So what it's saying is column names, then the data set. In this data set, add this as a column name. So age, gender, all this as column names. So if I was to add that, should add as column name. So that's column name added, and I want to check how many liver patients do we have and how many we don't. So there are about 167 non-liver patients, and about 116 are liver patient. So again, this data set contains about more than 583 observations. Let me just clear the console. It's getting a bit untidy. Control L. And okay, and the second step is to prepare dataset. So what I intend to do is I wanted to get 20 set for test sample and 80% of the data for the training sample. So you can just calculate that. So I want to set a seed. So it generates random number from training sample. So I want to create that AD training sample, structure of that, so you can see it generates random number. Then I want to get the training set, then the test set. If you want to see the structure, you can see all the columns, and in the training set we got 466, just about 80% of the data observations. And if I was to now do, so now what this should do is for each of the taste and training data set, it should have about 20 to 30% of liver patients, so which is kind of equally distributed into training and test data set. So you can see that there is about 70% is yes and 30% is no for training. And for test data set, again, it's about 25 to 73%. And moving on to step 3, training a model on the data set. So for this classification, we'll be using a package called c5.o algorithm package. And so I've already downloaded that, installed that package. All I have to do is just call that library and apply that to a model. And for us to do a model, you can see there are about 466 sample data observations. There are about 27 tree size. So you can see the tree size means like branches from top to bottom, and about 10 predicted observations, minus the last one, which is liver patient or not. Let's click summary. This is quite interesting though, because it has about you can see it's quite long summary. So from here you can see from age greater than 42 and above, which has about there are about 185 of them are greater than 42 age, and one has detected as a cancer patients. And you can read further down. Gender, there are about 88 male and 15 are detected as liver patients. There's no female which are greater than 12 which has liver patients. And you can read further down. And here's the confusion matrix, so call it. So how confusion matrix works is you can see this side. I'll show you further down how to read this. So you can see which attribute it has used to predict what percentage. So direct belief bin has been used by 100%. This variable has been used for 72%, so on and so forth. So bear that in mind. I've got this on this over here. So then what I calculated was the accuracy of the machine learning. So to do that, what do you do is you look at the true positive and true negative. Means we have correctly identified these are positive and this is negative. True positive and true negative are the correct predictions, whereas this one we're saying false negative. We're saying there's no this is not they are not cancer patient, but they could be a cancer patient. Whereas this one we're saying positive, there are about 55%, 55 patients which has liver related disease, but where they might not have a liver a disease, disease related to liver cancer or something. So how to calculate accuracy of the model is to get the true positive and true negative, add them up, divide by the total number of observations. So this is what I'm doing here. So it comes up to about 68%. So now hold on to here about 68%. This is quite interesting number. So we'll go back to our machine learning, see if the model has successfully created or not. Let me just refresh. Oh, it says completed. So what I would do is click under evaluation model, click summary mode, and wow, it's you can see area under curve AUC is about 69.5%. So which is similar to AWS machine learning prediction. So about 69%. So it's quite similar to what we have produced in R. Let's go back to again and let's try and explore the performance. So here it is. We're saying about 104 are true positive, 18% 18 are true negative. Is that true in R? So true positive, it's saying about 104, whereas here it's saying 81 true positive. True negative about 18, and true negative we've got about 316. What about the false positive? So false positive is about 55. In ML, AWS ML is 32. False negative is about 20 observation false negative, and here it says about 14. The thing is that the number, the percentage it has comes out is about 69%. Yeah, it's not great model because it's not nowhere near to 1. If it is more than 80%, I would say the model is quite good. You can use that and improve that. But because of our model is not great, how can you improve? Let's try and evaluate further our model. Having seen this, you can change the threshold here if you want. So keep an eye on this percentage here. So that's 72%. If I was to move to my left, there's about 72%. As I move my cursor, it changes. So if I was to come back here, come to my right, it's not looking great. The models are probably depends on the data set. I think you've got very small data set, so it might be because of that, or how data is presented. or maybe it's just a random data set. There's no correlation, probably. But I think 71% is too low. 0.661 is very, very low. So before I go ahead, let me just clear out all these model, and we'll continue in R. So to clear or delete all the models, go to Amazon Machine and Dashboard. You'll see all your models here. Select all the models and action, and under action click delete. So it should delete. There you go. It's has no models. So now coming back to R, let's try and improve if we can, what is possible. So first, what I'm doing is trying to predict the lever with using lever model and lever test. So remember the lever model we've predicted here, we have summarized here. I'm using that to predict the test data set here. I'm using gmodel library, and I'm going to convert that information into cross table. So cross table looks like this. It's quite readable to human eye, so which is quite interesting. Again, this is like true positive and true negative, all that. So you can see we've accurately predicted about 10 of them are accurately predicted, saying yes, there are about 16 of them has got liver, identified as liver patients. And this is just all I've just copied. And if you want to further improve the model, what I've done is I've used there's a boosting accuracy using decision tree, again using the C5.0 training, and saying trail 10, so saying iterate 10 times. So let's see how it performs. So okay, this from about 27 tree size to now it goes down to 2. That's quite a significant change. Let's summary. What does it give us? Summary. Okay, so you can see it has completely missed out the false false positive and false negative. So it's completely missed out those. It's probably because I've said use iteration 10 times. Let's see if I was to change rather than trail equals 10, let's say 5. So again, no matter how much I try and improve this model, but it's going to produce same result. So we'll keep the trails as 10. Summary, then try and predict, then cross tabular. Again, you can see we've got predicted about using the model in the test data set. We've got about 86 of them. We have accurately predicted that they've got liver. They are labeled as liver patients. So in conclusion, you can see, like for instance, you can use AWS and R, but if you have, imagine if you have terabytes of data to crunch, you can use AWS. But if you have a smaller data set, you can use R. Probably you can use try and test your code before in your R environment. Then try and use AWS just to see how it works. Then apply that into your real life applications and so on and so forth. So this is it for today, really. This is Yogesh from I'mYourDataScientist.com. Until then, next time, see you, and have a great Christmas and Happy New Year. This is, of course, this is nearly Christmas time, so take care and be safe.